fires are now in the top 20 most destructive wildfires in California history.
Firefighters in Los Angeles are making an all-out aerial assault with helicopters dumping water on the spreading flames.
And at least 180,000 people have been forced to evacuate.
California is engulfed in flames. Year after year, wildfires grow more frequent, more intense, more relentless. Entire neighborhoods are reduced to ash. Thousands are displaced, and damages soar into the billions. The Palisades and Eaton fire alone have devastated communities, destroying thousands of structures and forcing nearly 200,000 people to evacuate. The economic toll is staggering, with losses estimated at over $250 billion, making these fires among the costliest natural disasters in U.S. history. More than 124,000 people have sought federal assistance. Yet, even with the flames contained, the destruction remains. Thousands are homeless, entire neighborhoods have been reduced to rubble, and rebuilding would take years. But why does this keep happening? One major reason is that most homes are built with wood, which is a highly flammable material that allows fires to spread quickly, igniting homes in minutes and turning entire neighborhoods into ash. But what if we could stop the destruction? What if we could build homes that fire cannot touch? This is where ultra-high performance concrete comes into play, also known as UHPC. Unlike wood, UHPC does not burn or contribute fuel to a fire. It is designed to withstand extreme temperatures, resist structural failure, and last over a century with minimal maintenance. With its superior strength and durability, UHPC has the potential to revolutionize fire-resistant construction, creating buildings that can stand up to flames instead of fueling them. At its core, UHPC is an advanced high-performance version of traditional concrete, engineered to maximize strength, durability, and fire resistance. Unlike standard concrete, which relies on coarse aggregates, UHPC is made with precisely engineered mix of cement, silica-based materials, water reducers, and reinforcing fiber. This creates a dense, ultra-strong matrix that is significantly more durable and resistant to extreme conditions. What makes UHPC unique is its exceptional strength and longevity. It is up to 10 times stronger than regular concrete, with compressive strengths exceeding 150 megapascals compared to the 20 to 50 megapascals in standard concrete. This immense strength allows UHPC to withstand heavy loads, extreme weather, and high temperatures, making it the ideal choice for fire-resistant structures. Beyond its strength, UHPC also excels in fire resistance due to its low permeability and fiber reinforcement. Traditional concrete can suffer from spalling, where trapped moisture rapidly turns to steam under heat, which causes the concrete to crack or explode. But UHPC's dense microstructure minimizes moisture absorption, significantly reducing the risk. Additionally, it contains fibers that help maintain structural integrity during a fire, preventing crack from spreading and reinforcing its resistance to heat damage. With wildfires becoming more frequent and destructive, the need for stronger, fire-resistant materials has never been greater. UHPC offers a durable, high-performance solution that can help make homes and buildings more resilient. But what if we could take this material a step further? With advancements in 3D printing technology, UHPC can now be used to rapidly construct fire-resistant homes, offering a faster, more cost-effective way to build safer communities and rebuild homes lost to wildfire. Right now, conventional construction relies on manual labor, heavy machinery, and traditional building methods, which come with significant limitations. Building a home can take months or even years due to supply chain delays, labor shortages, and the complexity of coordinating multiple teams. Additionally, construction is one of the most hazardous industries, with workers facing risks of falls, equipment-related injuries, and exposure to harmful materials. 3D printing has the potential to revolutionize the way we build, offering a faster, safer, and more efficient alternative. Instead of manually assembling materials, a large robotic printer follows a digital blueprint, which extrudes layers of concrete-like material to create entire structures on the site. This technology significantly reduces construction time and labor requirement, while also allowing for more precise and innovative designs. One of the biggest advantages of 3D printing in construction is speed. A traditional home takes 4 to 12 months to complete, while a 3D printed home structure can be built in as little as 24 hours to several weeks. Additionally, cost effectiveness is a major benefit. By reducing labor costs and minimizing material waste, 3D printing makes housing more affordable and sustainable. Another key advantage is precision and strength. Since 3D printers follow a digital design, human error is minimized, and structures can be optimized for efficiency and durability. Additionally, 3D printing allows for more complex architectural designs, making it possible to construct curve-optimized and previously unfeasible structures without limitations of traditional formwork. Countries like the Netherlands, China, and the US are already experimenting with large-scale 3D printing of homes, proving that this technology is not just theoretical, it's happening now. If we combine 3D printing with UHPC, we could rapidly deploy fire-resistant communities in high-risk wildfire zones, offering a safer, more resilient future for construction. While UHPC and 3D printing offers groundbreaking advancements for fire-resistant construction, several challenges must be addressed before they can be widely adopted. One of the biggest obstacles is cost. UHPC relies on high-performance additives like silica fume, coarse powder, and steel fibers, making it significantly more expensive than traditional concrete. Scalability and speed also remains hurdles. While 3D printing can significantly reduce construction times, large-scale projects require advanced robotic systems capable of printing at greater heights and width without compromising stability. Additionally, while UHPC is highly fire resistant, exposure to extreme temperatures can still cause cracking or surface damage. Beyond material challenges, 3D printing technology itself still has limitations. Most current 3D printing robots has a limited build area, making it difficult to construct multi-story buildings or skyscrapers efficiently. Also, 3D printing construction requires specialized robotic system, custom printing setup, and extensive material research, making large-scale adoption costly. While 3D printing eliminates some labor, human workers are still needed for assembly, reinforcement, and finishing tasks. Despite these challenges, the potential of 3D printing in construction is only beginning to be realized. The industry has only been commercialized for about a decade, and as research and development improves, robots become more advanced, and materials become more optimized, 3D printing will become more scalable, faster, and eventually more cost-effective than conventional construction. Picture this, an entire city rising in just weeks, homes that don't burn, don't crumble, and don't fail, built faster than ever before. It's not a dream, it's the future of construction, and it's coming sooner than you think. With the rapid advancement in automated construction and materials technology, this vision is becoming more of a reality every day. Of course, there's still research to be done and challenges to overcome, but as technology evolves, costs decrease, and adoption grows, 3D printing with UHPC has the potential to reshape the way we build, making our communities stronger, safer, and more resilient. If you found this video interesting, don't forget to like, subscribe, and check out my other videos. So stay tuned for what's next.